A black hole's boomerangs. Astronomers dissect the energy flow in a distant galaxy. Astronomers have deciphered the dynamics of yet another great trick that monster black holes can play. In many galaxies, jets of energy are squeezed outward by the black hole that lurks at the center, and go shooting off in opposite directions into space. But in a few bizarre-looking galaxies, the jets take the form of four beams in the shape of an X. Now, radio astronomy observations have shown how that happens. Astronomers have no trouble understanding how black holes, objects so dense that not even light can escape the tombstone grip of their gravity, can become the most luminous objects in the universe, powering quasars. The pressure in the fat, fiery swirl of doom that surrounds a black hole expels high-energy particles from the top and bottom of the doughnut. But a galaxy known as PKS 2014-55 is different. This old, elliptical galaxy is about 800 million light-years from Earth in the constellation Telescopium, and its jets are shaped like two boomerangs placed back-to-back to form an X. Why? Perhaps, some astronomers thought the central black hole was wobbling, like a lawn sprinkler throwing jets in different directions. Or maybe a pair of supermassive black holes were colliding. But observations by an international group of astronomers with a powerful new South African radio telescope, MeerKAT, have provided an alternate explanation. The dynamics of the jets, it seems, more closely resemble those in an elaborate Las Vegas fountain, with water going up and down and flowing in designer configurations. In this case, superhot gas is being pumped up 2.5 million light-years into intergalactic space. It then cascades back and splashes sideways off the center of the galaxy, sculpting an X in the cosmos, as if marking a treasure. Material falls back and gets reflected around the center, said Fernando Camilo, chief scientist of the South African Radio Astronomy Observatory, which built MeerKAT. The team, led by William Cotton, an astronomer with the National Radio Astronomy Observatory in the United States, reported its results last week in the monthly notices of the Royal Astronomical Society. Key to the results was the new MeerKAT radio telescope, an array of 64 antennas located in the Karoo Desert in South Africa. Computers can combine the data from the individual dishes to create radio images with exquisite detail. MeerKAT was designed and built as a precursor to one of the great dream projects of astronomy, the Square Kilometre Array, a giant assembly of hundreds of radio dishes with a total collecting area of a square kilometre. Half of it is being built in South Africa and half in Australia. MeerKAT is one of a new generation of instruments whose power solves old puzzles even as it finds new ones, Dr. Cotton said in a statement issued by the South African Radio Astronomy Observatory. In their paper, the scientists described in detail how the fireworks in PKS 2014-55 work. First, energetic material is launched outward in two opposite directions by the central black hole. But intergalactic space is not empty, it is filled with a thin hot gas. As the jet encounters this gas, it slows and eventually stops. Material from the stalled jet then begins to fall back down into the galaxy from which it came, accumulating around the edges of the main jets like mist tumbling down the outside of a fire hose. Eventually, the return flow hits the galaxy itself, and the cloud of hot gas that typically inhabits the centers of old galaxies. The pressure of this gas deflects the flow of the returning streams, the way a pebble in a stream redirects the current. Which way the flow goes from there, Dr. Camilo said, depends on how the ellipse of hot gas is oriented relative to the two returning hydrodynamic flows. In this case, the streams are again steered in opposite directions, creating the two boomerang shape features. It's all quite neat, Dr. Camilo said.